Assalamualaikum warahmatullahi wabarakatuh. Okay, now we come to the second part of chapter 6, which is application of partial differential equations. Okay, for this part, we will discuss about one-dimensional heat equation and another one-dimensional wave equations. Okay, now focus on one-dimensional heat equation. Okay, consider we have a thin rod with length L. Okay, this is our thin rod and the length of the rod is L here. Okay, the rod has the initial temperature, okay, the function of Fx. Okay, the function of Fx is the temperature. Okay, the temperature throughout the rod, okay, meaning from x equals to 0 to x equals to L. To x equals to L. At t greater than 0, the temperature are held at 0. Okay, the temperature are held at 0. Okay, so the temperature uxt, meaning u in the function of x and t in the rod, is determined from the boundary value problem. Okay, this is the second order PDE. Okay, this is second order PDE. PDE with K. K here is the thermal diffusivity of the rod. Thermal diffusivity. Okay, and we have boundary condition. Okay, we have boundary condition, meaning u 0t, meaning when x equals to 0, temperature equals to 0. Uxt here is the temperature. Okay, uxt here is the temperature. Okay, so then when x equals to L, the temperature also equals to 0 at t greater than 0. Okay, this is the boundary condition. And we also have initial condition. Okay, initial condition is when t equals to 0. So we have uxt, so t equals to 0. We have fx, the function fx. Okay, now let me solve the heat equation subject to the given condition. Okay, first example. Okay, we have second order partial differential equation. Okay, delta u over delta t equals to delta square u over delta x square. Okay, this is second order PDE. And we have x greater than 0 and less than 4, t greater than 0. Okay, we have the boundary condition. Here is our boundary condition. Okay, when x equals to 0, uxt equals to 0, meaning the temperature equals to 0. This is the uxt is the temperature. Okay, then when x equals to 4, then the uxt or temperature equals to 0, meaning we have the tin rod, for example. Okay, so this is the rod. We have the length of the rod is 4. Okay, since this is one-dimensional heat equation, so we only consider at x-axis. So the temperature at x equals to 0. Temperature equals to 0. When x equals to 4, the temperature also equals to 0. Okay, this is the boundary condition. And we also have initial condition or initial value or initial condition. Okay, when t equals to 0, we have fx equals to x squared. Okay, x squared here our fx. For x greater than 0, less than 4. Okay, how to solve this? First, okay, we make the particular solution in terms of x and t. uxt equals to xx and tt. Okay, that's what we cover during the previous topic, which is separation variable. Okay, so from this particular solution, delta u over delta t, meaning we differentiate u with respect to t. So we have x t prime. So we have x t prime. Then delta u over delta x, meaning we differentiate u with respect to x. So we will get x prime t. And del square u over del x square equals to x double prime t, meaning we differentiate this one more time, so we get x double prime t. Then we substitute all this inside we substitute all this in our equation. So delta u over delta t equals to delta square u over delta x square. So delta u over delta t is this xt prime. So xt prime equals to x double prime t. Okay, to separate x and t, so we have to divide. So x double prime t over xt equals to xt prime over xt. Okay, meaning we divide both. Okay, meaning we divide both of these with xt. Okay, sorry. Divide with xt. So we get x double prime over x equals to t prime over t. Okay, look at here. This function independent of t, and this function also independent of x. So we can put as negative lambda. So we have x double prime over x equals to negative lambda, and another one, t prime over t equals to negative lambda. So x double prime equals to negative lambda x, and t prime equals to negative lambda t. So x double prime plus lambda x equals to 0, and t prime plus lambda t equals to 0. So we have these two equations. Remember, this is in the form of system level. So we have to apply case 1, case 2, and case 3. Okay, first we consider case 1. For case 1, lambda equals to 0. Okay. When lambda equals to 0, so we have x double prime equals to 0. Okay, we transform into auxiliary equation. It's become m square equals to 0. So m1 equals to m2 equals to 0. Okay, so we have real and repeated roots. Okay, for real and repeated roots, the general solution will become, so xx equals to c1 e m1x, so c1 e 0x plus c2 x e 0x. So we have c1 plus c2x. So this is for xx. And remember, we have the a boundary condition. So we apply the boundary conditions. So we apply boundary condition when x equals to 0, uxt equals to 0. So 0 equals to c1 plus c2 0. So c1 equals to 0. So we have c1 equals to 0. Then apply the second boundary condition when when x equals to 4, 4, and our x become 0. So 0 C1 plus C2 x, and our x we substitute with 4. So 0, okay, since C1 equals to 0, so plus 4C2. So C2 also equals to 0. Okay, this is for x. Okay, remember we have another term which is t. So another one is t. So t prime equals to 0, since our lambda equals to 0. So m equals to 0. So our t equals to C3, since we already have C1 and C2, so now we have C3 e to the power of 0t. So tt equals to C3. Okay, for this xx, so xx equals to C1 plus C2x. Okay, since C1 equals to 0 and C2 equals to 0, so xx equals to 0. Okay, so uxt equals to xx tt. So xx equals to 0 and tt equals to C3. So equals to 0. So uxt equals to 0. So we have, since uxt equals to 0, so meaning we have trivial solution. Then we proceed to the case number 2. For lambda less than 0. Okay, for lambda less than 0, so our equation will become x double prime minus lambda x, since our lambda is negative, less than 0 meaning negative, so equals to 0. So m square minus lambda equals to 0. So m square equals to lambda, m equals to plus minus set lambda, meaning m1 equals to set lambda and m2 equals to negative set lambda. Here lambda. Okay, since we already have m1 and m2, so our xx will become, and here we have real and distinct root. Real and distinct roots. So our solution will become, general solution will become, okay, now we have C4. C4 e to the power of lambda x, set lambda x, plus C5 e to the power of negative set lambda x. Or we can change into hyperbolic functions. C4 cos set lambda x plus C5 sinh set lambda x. Then we apply boundary condition. Okay, for boundary condition, when x equals to 0, x equals to 0. So 0 equals to C4 cos sorry, this is not xt, this is xx cos set lambda 0 plus C5 sinh set lambda 0. Okay, cos 0 is 1, so C4 plus, okay, since 0 is 0, so plus 0 equals to 0, so C4 equals to 0. So we have our C4 equals to 0. Then proceed to the second boundary condition. When x equals to 4, so our xx equals to 0. So 0 equals to C4 cos set lambda 4 plus C5 sinh set lambda 4. Okay, since our C4 is 0, so this is become 0. So our C5 also equals to 0 because C5 sinh set lambda 4. So we bring sinh set lambda 4 to the left hand side, so it's become 0. So C5 equals to 0. So our xx equals to 0 since our C4 and C5 equals to 0. Okay, then we repeat for the t. So t prime minus t lambda, because our lambda is negative, so t prime minus t lambda equals to 0. So m minus lambda equals to 0. So m equals to lambda. So we have C4, C5, C6. So C6 so we have TT equals to C6 e to the power of lambda x. So u xt equals to xx tt. So since our xx is 0 and t equals to c6 e lambda x, so u xt equals to 0. So this is also trivial solution. Now we proceed with the case 3. When lambda greater than 0. Okay, for lambda greater than 0, so our equation become x double prime plus lambda x. Since the greater than 0, so the value for lambda is positive, so equals to 0. Then our auxiliary equation become m squared plus lambda equals to 0. And from this, m equals to cert lambda I. So we have 0 plus cert lambda I. This is complex conjugate roots. Complex conjugate roots. So for complex conjugate roots, our general solution xx will become C7 cos cert lambda x plus C8 sin cert lambda x. Then we repeat by apply boundary condition. Okay, when x equals to 0, our xx equals to 0. Okay. So 0 equals to C7 cos 0 plus C8 sin 0. Sin 0. So C7 equals to 0. Then the second boundary condition, when x equals to 4, our xx equals to 0, so equals to 0. So C7, so since C7 equals to 0, so 0 plus C8 sin cert lambda multiplied by 4. Okay, so C8 also equals to 0. Okay, since we don't want the trivial solution, so zero equals to C8 sin cert lambda 4 sin 4 cert lambda equals to 0. 4 cert lambda equals to inverse sin 0. So we know that inverse sin 0 is n pi. So 4 cert lambda equals to n pi with n equals to any real number 1, 2, 3 and etc. So our lambda equals to n pi over 4 square. Okay, this is what we call eigenvalue. So our xx is C7 sin cert lambda x. So xx equals to C7 sin. Okay, so we substitute lambda with the n pi over 4 square. So cert lambda equals to n pi over 4 x. This is our xx. Okay, now for t. So we have t prime plus t lambda equals to 0. So our auxiliary equation become m plus lambda equals to 0. So m equals to negative lambda. Okay, so our general solution will become tt equals to, sorry, this is not C7, this is C8 actually. This is C8, not C7, this is C8, sorry. C8. So tt equals to C9 e to the power of negative lambda t. Then we substitute negative lambda with n pi over 4 square. So C9 e negative n pi over 4 square t. Okay, so our u xt, so it is xx tt. So we combine both. It's become C7 sine n pi over 4 x multiply with C8 e negative n pi over 4 square t. Okay, this C7 multiply with C8, we can put it as Bn. So Bn sine n pi over 4 x e negative n pi over 4 square t. This is our u xt. Okay, then by using superposition principle, so u xt equals to summation n equals to 1 to infinity bn sine n pi over 4 x e to the power of negative n pi over 4 square t. This is the half range expansion of sine. Half range expansion. And then apply the initial condition. Okay, previously we have already applied boundary condition. Now apply initial condition. Okay, initial condition is when t equals to 0. So ux0 equals to x square and x greater than 0 less than 4. So ux0 equals to summation of, so n equals to 1 infinity bn sine n pi over 4 x e to the power of negative n pi over 4 square t. T is 0. So since e to the power of 0 equals to 1, so we have summation of n equals to 1 infinity bn sine n pi x over 4 And our uxt actually is our fx, so equals to x squared. Okay, now we can apply. So Bn equals to, okay, we can apply the Fourier series. Okay, Bn equals to 2 over L. So the Fourier cosine series. 2 over L from 0 to L fx sine n pi over L x dx. So since our L is 4, so 2 over 4 from 0 to 4 x squared sine n pi over 4 x dx. Okay, so we have two functions, x squared and sine n pi over 4x. So we can use IBP. So we can use tabular method to solve this integral. So we have u and dv. So our u is x squared. So x squared, and our dv is sine n pi over 4x. Okay, we differentiate x squared, we get 2x. When differentiate 2x, we get 2. Differentiate 2, we get 0. Then we integrate sine n pi over 4x, we get negative 4 over n pi cos n pi over 4x. Then we integrate again, we will get negative 16 over n pi square sine n pi over 4x. Then we'll integrate one more time, we will get 64 over n pi cube cos n pi over 4x. Okay, this is a tabular method. Remember the sign, plus, minus, so we can multiply. Okay, we will get, okay, 1 over 2 in front. So since we have 2 over 4, 2 over 4 is 1 over 2. Since we have 2 over 4 here, 2 over 4 is 1 over 2, so 1 over 2. Okay, remember to put 1 over 2, so negative 4x squared over n pi cos n pi x over 4 plus 32x over n pi square sine n pi over 4x plus 1 to 8 over n pi cube cos n pi x over 4. Okay, the interval from 0 to 4. Then we can substitute. We will get to 1 over 2 outside. So negative 64 over n pi cos n pi plus 1 to 8 over n pi square sine n pi plus 1 to 8 of plus 1 to 8 over n pi cube cos n pi minus 0, minus 0, minus 128 over n pi cube cos 0. Okay, we will get negative 32 over n pi cos n pi plus 64 over n pi cube cos n pi minus 64 over n pi cube. Okay, this is our Bn. Okay, now we substitute this Bn into our superposition principle, which is UXT here. Substitute into here. Substitute our Bn into here. So we will get UXT equals to, okay, here the summation of n equals to 1 Bn. Our Bn is negative 32 over n pi cos n pi plus 64 over n pi cube cos n pi minus 64 over n pi cube. This is our Bn. Sine n pi over 4x e to the power of negative n pi over 4 square t. Okay, that's the final answer. Okay, that's all. Thank you.